Hello everyone, Matt here. Before watching, I strongly recommend you watch the full furnace tutorial first, since there might be some references to the first video that will help you understand the procedure better. In the first part of the tutorial, we'll learn how to make our furnace procedure like the one we did in the full furnace tutorial. It supports multiple recipes and fuels and is very flexible overall. First, I'll explain all the different procedure blocks in the main procedure, so that we'll better understand why I use certain blocks where I did. Afterwards, I'll create the entire smelting procedure block by block and explain what I'm doing in detail. After watching this video, you should be able to understand how to create a similar procedure in the future. If you don't want to understand the background, but only want a working furnace, feel free to watch the simplified full furnace tutorial. However, I still recommend you watch this video as well, as it will help you solve issues with it faster in case any occur. Now let's get started with the procedure. Before I start going over it block by block, I'd like to go over all the different blocks and features we'll use, where to find them, what they do, and when to use them. You can skip this part if you're sure you know what each one of them does by jumping to the timestamp shown on the screen. Starting with the basic blocks, the if block can be found under the logic and loops tab. Its functionality is pretty self-explanatory. If the condition in its input slot is true, the do segment will be executed. You can extend it by clicking the gear icon, which opens a small procedure-like editor. In it, you can either add else if blocks or an else block at the end of it. Else if blocks are executed when all previous ifs and else ifs fail and its input condition is met, while the else block executes only if all the previous conditions weren't true. Add and or blocks can be found under logic operators. They merge two conditions to make them fit in a single input slot. AND is true when both conditions are met, meaning that both blocks in the input slots output the value true, and false in any other case. OR is only false when both conditions are false and true in any other case. Under the same tab, you can find the number comparison block. It compares two numbers with the operator specified using the drop-down menu. On the bottom of the tab, you can find the item block comparator, which is true when the items provided in the input slots are the same. This can be useful when we want to check, for example, if we have a certain item in a slot. We'll also use the constant and number operator blocks that can be found under math. They are useful when we want to increase or decrease the number of items in a certain slot. We'll also use temporary local variables, which can be added in the top right corner and then accessed with blocks found under custom variables. The get blocks return values of the respective type, while set blocks set variable values to the number given in the block's input slot. Note that these values are not stored after one iteration of the procedure ends, so you have to set their value every time you start a procedure, or it might cause some undefined behavior. To store data to the furnace permanently, we'll use MBT tags. They can be found under block procedures. Get blocks are at the top and set blocks are at the bottom of the tabs list. They don't have a drop-down menu like the local variables, which means that you have to access them using their names. They are also bound to coordinates, which in our case are the same as our blocks. If you try to read values of a variable that has not been set before, you will get a so-called default value, which in our case is 0 since we use number tags. The last kind of procedure blocks is used for interaction with inventory slots. They all appear on the block procedures tab, and I'll list them in the same order as in MCreator, so in case some of you follow along, you'll be able to find them more easily. The first one is get item from slot, which outputs the item that is in the slot of the block at certain coordinates. Right under it is the get number of items from slot block, which outputs a number. A few blocks lower is the remove items from slot block, and a few more blocks lower is the set an amount of something in slot. With this, I'll often use the block item constant from the Minecraft component section. Moving on to the actual procedure. It first sets a temporary local variable to store which is the ID of the previous recipe. We want this so that we can later reset the smelting timer in case the recipe changed from the last time this procedure executed. Next, I add an if statement that checks for the current recipe. A valid recipe means that there are enough items of a certain type in the input slot, as well as enough space in the output slot. This means that it either contains no items or there are fewer items of the same type as the recipe's result than a recipe cycle will create. Since I'm creating a diamond recipe, I'll be checking for diamond ores in the input slot and diamonds in the output one. The recipe will also output 2 items per smelting cycle, so I want to make sure that there can only be 62 items in the output slot for the furnace to continue the smelting process. I'll also assign a positive integer recipe ID to the block's MBT number tag named recipe. This recipe's ID will be 0. To add more recipes, we simply add more else if statements with matching recipes. In case this if statement doesn't match any recipe, we want to set the ID to -1 to make sure the procedure recognizes any other case as if there is no recipe. For the smelting timer, I'll use an MBT tag called timer. I want to reset this number to 0 every time the recipe changes. For that, I'll add an if statement that will compare the previous recipe ID we saved at the beginning of the procedure with the new ID. If the numbers don't match, the recipe timer will be reduced back to 0. Here I'll add an if statement that will contain everything that we want to happen in case the recipe is valid, which means that we want to check for whether the recipe ID is positive or not. Now inside I'll add another if statement that will check if the item smelting cycle is already complete. I want my items to cook for 20 ticks, so my smelting cycle will be over when the MBT tag timer is 20 or more. Now we can define what happens with the diamond ore when the smelting cycle finishes. So I'll add an if statement that checks if the current recipe ID is 0, and then define what happens. I'll remove one item from the input slot and add diamonds in the output slot. To do the latter, I'll use the set an amount of something in a slot of a block procedure block. Set the slot number to 2, get the number of items in that slot, and using the math block add 2 to the current item count. As well as process any current recipes, we want to make sure that the timer reduces back to 0, so I'll add a block that resets it. Now, after we check for any potential finished smelting cycles, we want to check whether we need to consume any new fuel. For the fuel level, I'll use an MBT number value named fuel. So this first if statement will check whether this value equals to 0, which means that we ran out of fuel. I'll add another if statement that will check for 2 things, which is why we need an AND block. First, I'll check whether there are any fuel items left, which means that there are more than 0 items in the first slot. Afterwards, I'll check whether there are any items left in the input slot using a similar comparison. In the if statement body, we add another if statement that will work as fuel definitions. In my case, I'll check whether there are coal blocks in the fuel slot. If it is, we want it to remove that coal block and set the fuel amount to something like 200. We do this by setting the fuel MBT tag to 200. I also set a tag called max fuel to the same number because we'll be using that in the effects procedure to calculate the flame height. In case there are no items in the fuel or item slot, we want to reset the timer to 0, since we ran out of fuel and we wanted to break the smelting cycle. Now we need to implement the actual timer. First, we want to make sure that there is any fuel left by making sure that we have more than 0 fuel. In this if statement, I'll reduce the fuel amount by setting its value to its current value, reduced by 1. We also want to increase the smelting timer correspondingly, but we only want to do that if the current recipe is valid. In the end, I'll also calculate the remaining fuel percentage that is used both in the user interface as well as in the other procedure. First, I'll divide the current fuel amount with max fuel we stored earlier and then multiply it by 100 to get the percentage. Afterwards, we store this number in the fuel remaining MBT tag. At this point, we're done with the smelting procedure. Thank you for watching the first part of this furnace procedure tutorial. We now know how the smelting procedure works in detail. In the second part, I'll show how to add a few new recipe types, including recipes with multiple inputs and recipes that smell all items you put in the input slot at a time. I'll also explain how the effect procedure works in detail. If you're interested in the full tutorial, make sure to check out the previous video. Don't forget to subscribe, turn on the notifications, like for more content like this, and comment with suggestions down below. Stay tuned!